Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Dear judges, thank you for the chance to let us present our presentation. First, we would like to introduce ourselves. I'm Vincent as the team leader, and the team members are Bima and Windy. We came from Department of Chemical Engineering, Gadjah Mada University. In 2020, the world is attacked by coronavirus disease, or what we know as COVID-19. This virus attacks the respiration system and may cause death. A lot of people are scared because this virus spread rapidly and is very infectious. There are 78 million cases of COVID-19, with 1 billion people died all over the world. However, this strategy are still not enough to stop the spreading of COVID-19. We can see from the graph that the daily new cases of COVID-19 still increases every day. This situation is mostly caused by the lack of awareness of the society to follow the health protocols. The government has tried their best to remind the society to follow the health protocols. One of them is washing hands using soap. According to UCI Health, washing hands using soap is the most effective way to remove bacteria and virus. Washing hands using soap is more effective than hand sanitizer because hand sanitizer cannot remove all types of bacteria and virus. So, our idea to help solving this problem is making a new liquid soap. We name our product as All Soap, an innovation of hand soap from waste cooking oil recovery.
Currently, the whole world is struggling to cope with the COVID-19 pandemic, which is spreading very rapidly. One of the most embraced prevention methods is to wash hands with the soap and water because it is easily accessible to the general public. The soap we want to make is using raw materials such as waste cooking oil, bagasse, and orange peel waste. Making all soap in general is by purifying the waste cooking oil using bagasse at the first step, then followed by a saponification reaction using a kalium hydroxide solution, and then the last step is mixing orange peel powder as a fragrance and also coloring. Several experiments show that bagasse could be a low-cost solvent for some volatile materials, such as heavy metals, phenols, and dyes. Bagasse also can be used to purify waste cooking oil and reduce its acid number. The high capacity of sugar production has an impact on the abundance of bagasse. The global production of bagasse in the world reaches 1.91 million tons, with Brazil as the largest contributor of bagasse. 1 ton of sugar canes can be processed into 260 kg gas. Waste cooking oil is domestic waste that results from cooking with vegetable oil. The waste cooking oil produced in each country varies depending on the amount of vegetable oil used. According to research from the International Council on Clean Transportation (ICCT) in 2019, Indonesia produced 157 million liters of waste cooking oil, which come from restaurants, hotels, and schools in urban areas. Okay, the next part is research method. In the research method, there are 3 techniques. The first one is data collection technique and information. The method that we use to write this paper is by studying and collecting data from libraries that are related to the problem. The data can be collected from books, paper, and information on the internet. The types of data collected are qualitative and quantitative. Second one is data processing. The data and information obtained were processed using a descriptive analysis method based on secondary data. And the last one is data analysis. The data that has been collected is selected logically and systematically to find the solution of the problem that have been formulated. And then for thinking frameworks that support research, based on several data that have been collected, we choose the best method to get the optimal result. The variables that we use in this research are the independent variable, which is the adsorbent particle size and soaking time. Depend variable, which is the water content and acid number, and then control variable, which is the ratio of bagasse and waste cooking oil.
So, now we are in our result and discussion part. In this research, we chose 3 papers as our basis for literature study. They are Gadjah et al., Robbia et al., and Mada and Octavia et al. On our analysis, we used the experiment that has been done by Robbia et al. Because it has the best result of purification and the fastest absorption time. In figure 1, we can see that the smaller absorption size and the longer of sorting time has the best result. We can look at in figure 2 that the reduction of water content is increasing. From figure 3 and figure 4, we can see that the smaller of absorption size and the longer of soaking time gave the best result of reduction of acid number in the oil. For the properties of all soap, we use the experiment by Vincent et al. 2010. We assume that the physical properties of liquid soap by the relevance of research is about the same. From this experiment, the result is suitable with the SNI for the liquid soap. This research used 3 kinds of analysis to know the feasibility of soap. Here are economy analysis, SPACEUP2021 analysis, and selection matrix analysis. Economy analysis shows that the value of POT is 1.14 years, IRR is 42.37%, and BEP is 57.75%. It means that also can be scaled out to the industry. Now we can go on the SWOT analysis. SWOT analysis is an analysis method to know the characteristics of this product. We analyze the strength, weakness, threat, and opportunity. Now we can focus on the weakness of all soap. The weakness of all soap is not durable enough. So, the solution that we use to solve this problem is by using small bottle packing size in 100 milliliters. This solution made all soap has been used up before the expired time. On the other side, there is the threat of this product. The threat of all soap is there are many productions of hand soap. They could be synthetic soap or natural soap. So, to face this threat, we need to do the selection method analysis. The aim of this analysis is to know the quality of all soap if we compare it with other soap. The criteria that we use are the ability to kill virus and bacteria, cost, safety, convenience, durability, and environmentally friendly. In this analysis, we give the weighting factor for each kind of soap in its criteria. The result of this analysis show that our soap has the highest score than the other soap.
The last part is conclusions and suggestions. We conclude that there are 3 processes to produce all soap, which are purification of waste cooking oil, orange essential oil extraction, and soap making. The physical properties of all soap are suitable with the standard of liquid soap in SNE. The result of economic analysis show that it is feasible to develop all soap into industrial scale. The SWOT analysis and selection matrix analysis show that the production of all soap is feasible and all soap can compete with other commercial soap. And we suggest that further research is carried out on which variables affects, such as using another type of absorbent, using another type of dye and fragrance, or using another method to produce liquid soap from waste cooking oil. So that's the end of our presentation. We believe that all soap is a good solution to reduce the spread of COVID-19. Thank you for your time and attention.